Cool.
Welcome to Azure Community Live. This is an online meetup about Azure for the community, created by the community. I'm your host, Lars Klint, and the idea behind this online meetup is that anyone, anywhere, with an internet connection, of course, can be part of the Azure community. So currently with social distancing, this is more relevant than ever, obviously. I also live in rural Australia. I live in the middle of nowhere, and I cannot go to meetups, even if I wanted to, in my nearest major city. So this is an opportunity for me to give back and kind of share my experience of what meetups could be like. And speaking of giving back, if you want to share your passion for Azure on whatever level that you might be at, then get in touch with us, either via Twitter, YouTube, or the Call for Papers link on our website. It can be anything Azure at any level. It's totally up to you. So let me get to the speaker for tonight. Nelly Sattari, and I think I'm saying that correctly, loves problem solving and is passionate about driving minds to engage with technology. She is a computer engineer and lead developer based in Sydney, Australia, and has spent her entire career involved in the IT industry. Her focus is on modern web applications, and she is indebted to her full stack development background and the knowledge she's gained there. And this experience led her to being awarded the Microsoft Azure MVP. So that's the like a community tip of the hat for Microsoft, going, yay, you did this, lots of cool stuff for the community, which is also why we're here. Inclusive local IT communities are her favorite playground, and where she facilitates knowledge sharing platforms, supports user groups like this one, and nurtures beginner expertise while steering clear of buzzwords, which we like. I'm not a big fan of buzzwords, for a more practical and tangible approach. So welcome, Nelly, and thank you for joining us tonight.
Thank you so much, Lars. And hello, everyone. Thanks for introduction. And yeah, shall we get started?
I think we should.
Right.
And if anyone has any questions, feel free to put them in the chat on YouTube. I will monitor that throughout the presentation, and I'll interrupt very rudely if there's a question that needs to be asked at that time. So take it away, Nelly.
Sure. All right, I'm going to talk about real-time serverless applications today with using Azure SignalR services. As Lars said, my name is Nelly Sattari, and I'm a tech lead and developer, and I'm Microsoft Azure MVP. This is my Twitter handler. Please feel free to contact me and follow me and get in touch and ask if you have any questions after this session as well. So I live in Sydney, same to Lars, not in the rural area though, but yeah, it's beautiful Sydney. So our agenda for today is mostly like a general idea about what real-time applications are, because I don't like to talk about how, I just like to talk about why we need something first. And then I introduce Azure SignalR service to you, and then I'll share some serverless approaches with you, which is interesting using those with Azure SignalR service. Well, what kind of candidates are the best candidates for real-time applications? We all know perfectly fine that all the social medias and the applications which send us notifications, they are the best perfect match. And some kind of applications like online datings, where you need to be quickly responsive to the people, otherwise they don't meet with you. Or some kind of, like the dashboards, incident dashboards. I used to work in the fire like incident area, and then we just had a big dashboard, and if anything happened, everyone should immediately see that. Similar to the COVID situation, which we need a dashboard to track the kind of situation, what's going on around us. And any kind of tracking application similar to Uber, or shipping, like tracking your shipping package, sometimes tracking your kids in the school car, where you need to see the live location. Online gamings, where you will lose the game if you have even 1 second delay. And any kind of bidding applications, where you want to bid something immediately and quickly see the other responses. I had this experience with this bidding application, so let me tell my story. We have a beautiful, I work in the city, Sydney city, and then we have a beautiful like a reception, which we buy every week, like a luxury and like a beautiful big flower bouquet, and it's quite expensive. So at the end of the week, we are not going to throw it out because we are the financial company. So we try to put in the bid, and anyone in the company can jump to the website and place their bid. And whoever put the highest one obviously will win. The problem is whenever I participate, I actually win the competition. And everyone just wonder, what's going on with you? Maybe you just put the highest bid, which is not true, or maybe you're so lucky, which I am. But anyways, that was not a really fair solution I used, because I used a very high technical solution, and that's this one. So first time I jumped to the website, I realized that, oh gosh, there is no real-time functionality in the website. It means that we cannot see immediately what's going on with other people. And I know that I need to refresh the page quite quickly, 2 minutes to the closing time, and I just get the, like the highest bid, obviously. And I always win, which is not fair, because you don't have enough transparency, and real-time applications help with transparency and equal data and information for people. Obviously, I didn't do that anymore, and I came up with this POC to my company, and I show you a little bit later. So in general, with the normal applications, when the client sends the request to the server, they will get back the response as form of HTTP protocol, and the connection will be closed. And whenever user needs any new things, pressing F5, they actually do this action in a loop. Real-time applications, though, they are not like that. They push the data when it becomes available, which means that you don't need to pull the data periodically. And it's great for high frequency, with the website with high frequency updates and, kind of event-driven architecture. How real-time applications in general work? This is not a new thing. We always have like real-time applications. Basically, there are three main principles, or let's say methodology, that these real-time applications use under the hood. One of them, which is quite old, is long polling, where clients send the request, server keep the connection open, it doesn't close the connection, and when the response becomes available, it sends back the response and then drop the connection. So still you have a lot of, you have to do it in a loop again periodically, but it's kind of, the connection time period is a little bit longer. A better version is, which is more recent, is server sent event, where is based on HTTP file features. And basically, when a client sends a request to the server, a persistent connection will be established between these two, and then only server can send like the recent update to the client, which we call it one-way communication. And unfortunately, it's not supported by all browsers like IE or Edge, so we need something more professional, which is WebSocket. So WebSocket, it's same, like client send the request to the server, the connection will be established persistently. It's not HTTP anymore, it's WebSocket protocol. And then it's two ways binding. So client and server can update each other immediately. So which one are you going to use? Long polling, server sends event, or WebSocket? You cannot say, oh, obviously WebSocket, because not all the, like the old browsers maybe don't support it. It depends on the capacity and capability of servers and clients. So you basically have to implement all of them to make sure that you have enough coverage, which is maybe not the best idea. That's why SignalR came around. SignalR is an open source library which came around to simplify adding real-time functionalities to the web applications. And basically it was shipped with ASP.NET around 2011. So SignalR, as a like the key benefit is it manages the transport methods under the hood. So based on who is connected to where, it realized that if WebSocket is available, go for it. Otherwise, it's gracefully fall back into other methods, which is a server send and long polling. So basically, you on the left side, if you consider your web application, you download your SignalR library with your NuGet package into your web application with ASP.NET Core or ASP.NET, and you ship and upload the whole package into your hosting area, which can be Azure or any IIS server. We have a problem with this, and that's pushing the limit. What does it mean? So normally, as you know, like in general, we know that the servers have limited resources in terms of CPU memory and connection capacity, which means that they cannot really handle, unlimited connections. Especially with persistent connections, it's even worse because persistent connections consume even more resources significantly. And I'll show you the reason. In the typical web applications, when a client one connects to the server, it gets back the response and will go away. Second connection, and same. So we don't have anyone persistently connected to our website, which is good because we don't, spend a lot of resources on these people. But with the real-time application, when anyone connect to the website, the persistent connections will be established. It means that the server will be overloaded much quicker than the normal web applications, which is a problem. As a rule of thumb, we know that how to manage this pressure, right? The answer is scaling out and load balancing in front of the servers. But with the real-time applications, when you have the collaborative clients where they want to send a message to each other and chat to each other, this is a tricky thing. Imagine that the client one wants to send a message or packet or whatever to the other clients. So it sends it to the server because it's connected to the server one. Server one knows who are connected to server one, broadcast the messages to everyone. But what about the server two and all the connected clients to server two? They don't get the response. They don't get the actual message, which means that we have a problem here. Again, as a rule of thumb, like a traditional system, they have to have a backplane. They have to set up a kind of SQL data, caching their responses, and then broadcast messages. Basically, it's kind of a custom manual approach, which needs time, energy, and basically cost. But if we are looking for a managed service with high availability, high scalability, and much better performance, maybe Azure SignalR service is something that we can look into. Azure SignalR service works as a proxy. It means that server is no longer taking any persistent connection. So the clients are not connected to the server persistently. But how they, get the messages then, how they get the real-time messages and data. That's the thing. The persistence are delegated into Azure SignalR service instead of actual web servers. Having the diagram, when the client connects to the server, instead of getting established connection with the server, it actually gets back the URL of Azure SignalR service in the cloud. And then in the next action, it can go and connect to that URL, which server provided. And I'll show you in action. And then the server and the Azure SignalR has this persistent connection, also SignalR with the server, which means that basically Azure SignalR service sits between client and server, and the data channel will be established through this Azure SignalR service between client and server. And now when the client decides to send a message to other clients, it actually goes to the Azure SignalR, and the Azure SignalR knows about everyone who are connected. So it knows that it should broadcast messages to servers. Well, I told you about that bidding website and the tricky things that I use, which wasn't nice. So I build a little quick, POC with this Azure SignalR to show how it's possible to use these modern solutions. So I opened, this application is hosted in Azure. I opened both of them in different browsers, so you can see. I jumped into the website, I put on my name. Another colleague of mine also still, jumped to the website. We put our bidding amount, and immediately the other people will see that. So there is no time to do any cheating or anything else. So the transparency is 100% there, and it's a fair kind of situation for everyone. So if I show you the network tab, you can see when maybe I zoom it, when the client send a request to the server, which is the top one, that's the, like the URL of my service server. It's not going to connect it and stay connected with that URL. It actually, on the button, you can see that a HTTP protocol changed to WebSocket, and then the other, like URL, bidding SignalR service, is the URL of Azure SignalR service. So the client is basically kind of proxy to that new Azure SignalR service, which is interesting. I'll show you how I created this Azure SignalR service, and you can see it's how easy it is. So there are different ways. You can use Azure CLI command, which is the command line. You can use the portal to create the service. You can use ARM template and any other approaches that we normally use. So I use this Azure CLI service, and I go to my portal to confirm that my SignalR, which I look for it, is basically created. And this is the SignalR service that is created. You can see all the overview, endpoints. You can see all the keys and connection strings and log files and settings and everything else about your system. Also activity logs and other stuff. Which means that you need to use this connection string and keys in your web applications to basically inform the web server that you are going to proxy the request to the Azure SignalR service. Having looked back again to my web application, this time I actually separated the SignalR from the application. So SignalR is not anymore sitting in the same and hosted in the same web server. So basically, you add the SignalR and inform the server that this is Azure SignalR service with this endpoint, basically. And in the config files, you have the connection strings. So basically, you host your Azure SignalR separate from SignalR, which typically solves a lot of scaling out and getting overloaded by, like thousands and millions of clients when they hammer the website. Well, what about, like serverless, how it can help us? Although we actually resolved a lot of critical issues with scaling issues and hosting things and, overloading the servers, but still we don't have the best practices, which means that the application that we designed, the ASP.NET application, you have to manage the connection of the SignalR service. You have to manage your sending and broadcasting messages. You have to manage your, probably in the real date, like live, you have to manage your database connections and all the other things which is related to one application, which makes your application monolithic design. So we need a way to break down this monolithic design into event-driven APIs, which moves us more towards microservices. Also, SignalR, as I told you, is shipped with ASP.NET, and it's quite tightly coupled with ASP.NET, which means that you have to be a .NET developer to be able to use this feature. But what if I'm not? Does it mean that I cannot use it? It's not the answer. So if we go with the serverless, if we use Azure Functions, it can, you can have this opportunity to write your application with any kind of language, JavaScript, Java, C#, Python, or anything else which is available for Azure Functions. I'll show you how you can switch your service to the serverless mode So basically, this is the service that we created. This is the Azure portal again. So in the settings section, you can see the service mode, which is, like classic or serverless. You can simply switch to the serverless, save it, and that's it. Done. Well, the next step is, instead of having that ASP.NET application, you need to build your Azure functions. First thing first, there is a negotiate function which is required. So no matter what you want to do, you have to have this negotiate function available. How it works, so when the client connects to the server, it actually hits the endpoint of this negotiate function. So that's the initial step to connect your clients to the Azure SignalR service. The negotiate function will send your the Azure SignalR service URL to your client, and it's the opportunity for you to connect. And obviously, negotiate function is going away because it's the serverless, so it's not staying around. And then, any kind of other functions that you want, again, you will hit the function endpoint, and then that function broadcasts the messages to the persistent connected clients. This makes me think that, when you send the message to the clients and things, you need to hit a broad endpoint of a function, which makes me think of, like the not dedicated VMs. Because when we talk about serverless, it doesn't mean that there is no server, but it means that there is no dedicated server which is going to be run all the time. It means that your function on the container will spin up and then execute your request and then go away. So that means that the clients are on listen-only mode. The server is not always running, so you have to hit the endpoint all the time. So you need to make sure and listen and choose carefully. If your application is too chatty, maybe serverless is not a good option. But if not, if it's kind of event-driven, it's a perfect match. I'll show you two examples, two demo, and you can see, probably you get some ideas. So let's say I want to build a flight dashboard center where, whenever and wherever in the world, when a flight is landed, everyone who are connected to this website can be informed. These days, because of this COVID-19, I don't have that much interaction with the website, so I use one of my, the recorded one, which happens before. So you can see that every few seconds, a new flight is landed, and then you get the update, and everyone on the website can immediately see the flight which is landed. And that's what we need from a dashboard. Any kind of incident dashboard will work same. So this is one scenario. How this Azure functions and things work with SignalR, I'll show you. There is a productive programming model in Azure Function, which as a developer, I really like it. That's triggers and bindings. Triggers, they are coming with Azure functions. Triggers are what cause a function to be executed and to run. It can be potentially, webhook. It can be any kind of other services which triggers your Azure function. And the binding, which means, when the function is executed, how you want to pass the response to the other services. It basically connects to the other services as the response is available. In our flight center scenario, there is a third-party application which kind of populates the new flights and the new feeds into the Azure Queue Storage. Azure Queue Storage have the data, and it can act as a trigger. So basically, it triggers the broadcast function, and the broadcast function, knows who are connected to the website and pass everything to the SignalR binding. So through the SignalR binding, it actually broadcasts messages to all other clients. If you don't want to use SignalR, you can use any kind of other services, as a binding and pass the message to those services. I go to the Azure portal and show you how they fit and sit in the Azure. So you go to the function app, you find your flight function, you have the endpoint for your function, you have all the details like activities, security things, monitoring and everything. And you can see the list of functions, which is negotiate, which is a required one, and obviously the broadcast function. You can test your function in the portal and you can see the triggers, which is the queue storage, and the output binding, which is the SignalR, which is amazing. If I want to show you the code, so every functions come with a JSON file and a JavaScript file or C# file or whatever. This JSON file basically configure your bindings and triggers. So basically you would say that my queue is the trigger and the direction is in, which means that this is the trigger. And my output binding with the direction out is SignalR, which can be replaced with any other services. And in your body of your, like the broadcast function, that's 3 lines that I have, nothing else. So basically when the queue storage trigger the function, it passed the feed and the message to the function, which is the flight. And then we kind of reform the message that we get because SignalR needs to know what is the message that we want to broadcast and who on the client side is listening to us. What kind of event on the client side is listening. We kind of, like build a new parameter and then we connect that new message to the binding, SignalR binding. That's the whole things for my function. Nothing else, no secret. Let's do another example and demo. Again, you get better idea how you can use this SignalR and Azure Serverless. I actually very much like conferences, especially IT conferences and tech, like environments, meetups, user groups, and especially the conferences that are really inclusive and they are fun, lots of parties, drinks, and like learning. I like those conferences. The problem is I'm an extrovert, so I don't have problem connecting to the people. But sometimes I see, some people who are shy or introvert, they just stay in the corner of the room, look at their mobile, not talking to anyone. And I really feel bad because I feel that's a great opportunity for us to connect to each other. So I was thinking when I was in the conference that maybe I need to have a kind of, web application where everyone who jumped to the conference, they actually scan the QR code, they connect to the website, and then they take a photo of themselves. And we analyze their photo by using AI and intelligence, like kind of services and engines. And we analyze their face. We just, all the attributes and things. We broadcast it to the people who are in the conference. And then in that, also you can say I'm extrovert or introvert. And that can be a good excuse or like kind of icebreaker to go and talk to other people, find them in your website and say, oh, this, like attribute quite match you or not. So I show you how I did a quick POC. It's not fully functional, but I show you how it works. So I basically scan this QR code, and you can do it even offline after this talk. You choose your photo, you take a photo of yourself and kind of selfie, and then basically you just upload your photo. Your photo will sit in Azure Blob Storage, which is a perfect scenario for saving images and things. Then you say, I am Nelly, or whoever you are. This is my character. And then you analyze your face and broadcast it to everyone who are connected to your website. So basically, everyone in you can see, the messages are broadcasted to you and say, Nelly, she's extrovert, and this is the details about her. How this application also work? I use cognitive services. I use Azure Functions and SignalR service. I'll show you how. First of all, we need to build Azure Cognitive Service to have a kind of AI engine to be able to analyze your picture. You go to the portal and basically you search for cognitive services. Also, you can run Azure CLI or ARM template. You create a new service, and then here it's heaps of services that you can use: face API, voice API, bots, and things. So you create a new face API, and then you just, as other services, you put the name, location of your service, pricing, and the stuff. You get the keys and endpoint connection string for your service, where you can use in your Azure functions. That's how we build the Azure Cognitive Service. That's it. So if I show you the network tab in my application, you can see that the first action is the negotiate function, which is called, and then this is the URL of this function, and then this is the response, which is the basically address of URL of Azure SignalR service, and your client connect to that. Then this is the architecture. So when you upload a file, it's going to be sitting in the blob storage. Then you get back the URL of your image, because it should be a public URL. Then you analyze your image. Basically, you trigger a function, which is the face detect. A face detect function will make a call to the Azure Cognitive Service. And then Azure Cognitive Service will analyze your image, send back the detail, and then your function has the ability to use its binding feature. So it basically output the message, the detail about you, to the SignalR binding, and SignalR broadcasts it to the clients who are connected. Again, looking at the portal, you can look for your function app. You can find your summer camp friend. This is the name of application because I feel in the summer camp with my friends when I go to the conference. You find your face detect application function. You can test it in your portal. You can see your code, and you can basically see the integration, which is the trigger is a webhook, and the output is SignalR service. Let's have a look at the function again. As I told you, a JSON file and a JS file. The JSON file is responsible to set your configuration. So basically, let me go back. Yeah, this is the trigger, which is the HTTP webhook, and the output basically is SignalR. That's it. And your body of the function is just these few lines where you get your key and endpoint of your Azure Cognitive Service. You, with any kind of, like HTTP, you can use Node HTTP, you can use Axios, you can use any kind of library to make a call to your endpoint, which is basically an API. And in the attributes, you say, this is the attributes I want to get, like, is the person have glasses? What is the age? What is the gender? How much smile you have? Every kind of attributes that you need. There are heaps of attributes available. And then at the end, basically, you just form your, again, new message, which you need to say who is in the client listening to me, what event, and then basically you say, this is my message, which I want to broadcast it. That's it. I basically provided a post in my weblog, and if you go to my weblog, you can find Azure service, Azure SignalR service with serverless, and I put as much as detail I could, like how to create a new function, how to install function, and how to test it locally, how to publish the functions from your local to your portal, and basically whatever you need to know about creating these things. And yeah, that's the whole thing I wanted to talk about. And basically, as a summary, we talked about Azure SignalR service, functions, and how to get the serverless approaches, and how to basically use cognitive service with combination of all these serverless approaches. Thank you so much.
Thanks very much, Nelly.
Thanks very much, Nelly. That was
really good. Oh, I can hear myself.
really good. Oh, I can hear myself on you.
Thanks.
On your feed, I think. Anyway, apologies if I come through
okay.
twice here.
Okay.
We didn't have any questions on the feed, but I was just thinking, I used SignalR when it came out in beta, and I don't know when that was. It'd been like 6-7 years ago, or even longer. And I haven't really touched it since. And so, oh, that's me.
Right.
And I was a bit blown away, to be honest, because it's come a long way, and it's really, really simple. Is it? How long does it take you
cool,
to?
Isn't it?
Yeah, how long does it take you to get up and running with it? Like, it's if I didn't know anything about SignalR, I have development experience, but I want to use SignalR on Azure. I mean, what's the learning curve like?
To be honest, the most important part is knowing how to run, get started with Azure Serverless to me. So once you get that concept, basically getting Azure SignalR to run SignalR service to run is just using the endpoint and like connecting to that.
Okay.
Which I tried my best to put everything in the, like the weblog. So it's an opportunity to see how you can get up and run with Azure serverless, like functions, as well as using the other services. So that's not really hard thing to do.
Yeah,
to me.
It's pretty.
Yeah,
incredible,
the most
to be
important
honest.
thing. Serverless.
Yeah, it's.
It
seems like almost a no-brainer. Like you.
And you can.
Yeah, go on.
You can use it for lots of fun, like activities and applications, which is something that I like it very much.
Oh yeah, and it's what was I going to say? It's a service that you were saying at one point that you don't want to use it for everything. If you have really high traffic, maybe this with serverless is not the right way to do it. But it just seems like it's an easy way to get really high reactive websites up and running. I think is that fair?
Definitely, yeah. Otherwise, you have to use the traditional, scenarios, installing and setting up the backplane, setting up SQL Server, and lots of configurations. Which maybe that's one of the reasons people don't really, are not interested to use it. But with this Azure SignalR, it's just so quick and actually nice experience.
Is it supported in all browsers?
Yes. It is.
Hey, for once.
Yes, because basically SignalR comes with this backend and a front-end library. So you can, I use the Vue.js application, and I used, front-end library for my application. And you just npm install your SignalR, and you can basically separate your front-end from the functions, which is kind of microservices. It's easy to use.
Yeah, that's very cool. I don't really have anything else because I was sort of engrossed in it, just trying to keep up. There's so much to kind of take in, so that was very cool.
Yeah, not a problem.
Where can we see you next, Nelly? What do you have other events that you are presenting at?
I have, yes. I'm not sure about the exact time, but probably in August, maybe.
Okay. Yeah.
Yeah, I might elaborate on a little bit of AI and serverless a little bit more on that function.
Well, that sounds very good. So, but thank you very much for joining us. That was very
Thank you for inviting.
And if you're watching this as the recording, feel free to get in touch with us if you want to present, or if you have ideas of who we should get on the show. Anyone can sort of suggest, and we'll try and chase it up. So, but thank you very much, Nelly, and have a good evening.
Thank you so much. Yeah, you too. Cheers.
See you, everybody.
Thank you. See you.